Um, Hi, everyone, and welcome to the ARDD workshop. I'm delighted to be here, albeit virtually. My name is Dr. Cassandra Coburn, and I'm the editor-in-chief of the Lancet Healthy Longevity. And today I'm going to be talking to you about longevity medicine and peer-reviewed publishing. So if I can get the slides to work. So aging is obviously an age-old problem. We've been trying to figure out how we can find a medicine that can cure age since the 11th century. And people have obviously tried 1,000,001 different remedies. Below pictured is The Fountain of Youth by Lucas Cranach the Elder, which is one of my favorite pictures when we think about medicine and aging, because really this is what everyone is looking for. The arrival of the old and the decrepit and the weak and the weary. And you just take a short and delightful bath in this fountain of youth, and then you emerge with all of your age washed away from you, extremely young and vital, all of your functions restored. And actually not showing, because I had to crop it, off on the right, there's a series of little booths where people are clearly like experiencing their renewed vigor and energy to the full. And that's essentially what the idealized idea of a medicine curing age is, or longevity medicine, some kind of magic bullet that can reverse the ills of age and restore us to a state of youthful vitality. But of course, it doesn't really work like that. However, what we have been discovering through longevity research over the past century or slightly less is that there are various mechanisms which can affect the rate of aging. And the idea of longevity medicine now is perhaps we can take some of those mechanisms, which we've discovered primarily in the basic biological sciences, and apply those and add those as an intervention. So I thought that I would just kick off with this really lovely history of longevity research from this superb paper, which was published last year in Nature, Kempinski et al. And what I really like about this is it shows how thick and fast the discoveries are now coming as people begin to take longevity research more and more seriously. So you start with caloric restriction being observed as enhancing lifespan, way back in the 1930s. And then we're moving all the way to identifying compounds which can hopefully act as various mimetics for genetic changes that we've observed in modern organisms as we get close to the present day. And of course, in the future, you'll see here is this hopeful section, that will find perfect biomarkers of aging, we'll find personalized aging therapies, and there'll be more clinical trials. And it's really this question, this grayed out future, that I want to address today as we talk about this idea of longevity medicine. Because fundamentally, we currently have a mismatch between what basic scientists are doing and what clinical science needs and wants. So when we think about geroscience in the 21st century, we're thinking predominantly still about these fantastic discoveries that are still mainly lab-based. So, here we have things like, insulin IGF-1 signaling, DAF2 signaling, and so on, FOXO and so on. You can see the same thing here with Wnt signaling, everything that, then converges on mTOR, FOXO signaling, SIR21. All of these different pathways together represent a huge abundance of richness for potential interventions. But very few of any of these have really been shown to have much effect on clinical research. By contrast, when we think about medicine and longevity in the 21st century, we're still very much thinking in this way. So we're thinking about clinical frailty, about how older people are much frailer than younger people, and how people live with that, cope with that, deal with that, how we can ameliorate some of that frailty. And we're thinking about how aging as a fundamental process leads to all of these various age-related diseases, and in my capacity from publishing a clinical journal, quite a lot of the research, in fact, I'd say that most of the research that we see and publish so far relates to this. So, much more about the age, the age-related diseases and frailty than about this great big central piece, aging. But as we all know, yeah, all right. And the other thing, of course, that really matters is population health and population aging. We all know that populations are getting older, which in itself is actually testament to the fact that medical science has advanced fantastically well over the last few centuries, which means that we're all living longer because we're primarily through a combination of public health, various vaccination programs, sanitation programs, and so on, but also the fact that things like infectious diseases and other essentially competing risks for human mortality have been removed. But this gives a huge shift in population demographics, which is of great concern to society fundamentally, because we're seeing a change in how people live and work and how society functions. So this is the sort of thing that currently clinical medical professionals are concerned with, and much less the mechanisms of aging. So the Lancet Healthy Longevity had to think about this question when we launched, which was almost exactly a year ago. What is longevity medicine? And how do we bring basic mechanisms of research of aging and longevity into a clinical medical sphere? So this is what we came up with, and this is how we define the remit of our journal. It's not the absolute end of, but this is how we think about it. It's a multidisciplinary journal, and we want to encompass everything from early stage clinical research into the mechanisms of aging, way through to the epidemiological, societal research on changing populations, and clinical trials in all disciplines focused on older people, gerontological science, geroscience, and age-specific clinical guidelines. So this is very much from the clinical perspective of longevity medicine. And I'm going to argue in this presentation that this is what the field really needs to bear in mind as it starts its pivot towards being more clinically applicable. So this is really us trying to consider what longevity medicine is. And again, this lovely figure is taken from that same paper I highlighted earlier, because I think it really illustrates very, very nicely the kind of conflicts that we've got between early stage longevity research and where the clinical fields are. So here we've got a whole series. On the left, you've got all the sort of basic research. So this is genes and environment, hallmarks of aging itself, although you'll note that that's still a kind of amorphous, undefined state or process, disease and fed by chronic inflammation. And then on the other side, we've got this idea of the chronic diseases of aging and the various outcomes. So just to focus on potential interventions briefly, this is still very much where basic clinical research, where basic research is. What people are trying to do is they're trying to find interventions that either can mimic genetic alterations or can upregulate certain pathways or inhibit certain pathways. And people are looking still really at very much at the hallmarks of aging when they try and consider longevity medicine. So quite often we'll see research which looks, for example, at epigenetic alterations or telomere attrition, and is using this as a hallmark of aging and as an outcome in itself. And I'm here to argue that this is all very well and good, but if we want longevity medicine to become something that is feasible and actionable and fundamentally of importance to the wider sphere of clinical medicine, the field has to start looking here at outcomes of clinical interest. Because fundamentally, the basic research field needs to continue to focus on this, because we need to still understand these mechanisms. They're very far from being elucidated. But we need to start pivoting so that we can see, okay, say we do have some kind of mimetic, which we think will have an outcome fundamentally on the processes of aging. Well, if this is real and if this is going to be useful, we should see some effect of these outcomes of clinical interest. So here you have chronic diseases of aging, which, as you'll recall, I highlighted before, is being fed by the process of aging. So, your cardiovascular diseases, dementias, Alzheimer's, osteoporosis, sarcoma, and so on, all of these sort of wasting diseases. Where you want to put frailty is up to you in your particular camp of mechanistic outcomes. But you have also here disability, mortality, and geriatric syndromes. I've added lifespan. It's not feasible, obviously, to do lifespan studies in humans. Aside from anything else, we need several generations of researchers to undertake the task. But it's not a feasible outcome to put in the study. But we need to start thinking about how various mechanisms and basic research propositions, how they affect these outcomes, because these are the outcomes that clinical medicine are interested in. So it doesn't really matter to your average clinician if you can show that there is some kind of change, for example, in cellular senescence, right? No one cares that for a clinician whose medical focus is on improving people's lives, outcomes, health states, they're going to want to see that your cellular senescence, your change in cellular senescence, your measure of it, actually leads to some kind of fundamental result here. So this is me sort of banging home on the point a little bit more. This is really, I think, the most difficult challenge that longevity medicine faces right now. And it's difficult for a variety of reasons. First of all, we don't really understand the mechanisms of aging insofar as they relate to longer, bigger age-related outcomes like disability or mortality, lifespan, geriatric syndromes. Let alone how one intervention might have on some specific disease of aging outcome, like, for example, diabetes, your risk for diabetes. And it's nigh on impossible to test all of those outcomes. But it is important if we want to start showing that various, if we take this idea that longevity medicine is going to target aging, which in itself is a risk factor for a variety of different diseases, then you could argue that almost any alteration that's supposed to alter the basic rate of aging, basic mechanisms of aging, should lead to a change in one of these big outcomes. And this is something that I think people in the field really need to consider and be aware of, especially given that aging is not considered a disease. Now, we can argue that specific point until the cows come home, but it does beg the question, how do you get regulatory approval for studies? Because if you can't look at specifically at aging as an outcome, what are you going to look at and how are you going to make that clinically relevant while still being measurable and useful for the longevity field? And so COVID-19 has provided quite an interesting case study. Standard caveats about this is not something we'd ever have wished for, but now it is here, we should make use for it. We published this excellent comment by Cox et al. Earlier this year, and this is looking at examples of how we tackle immunosenescence to improve COVID-19 outcomes and vaccine response in older adults. And what they've done here, they've got a really lovely little table looking at the different potential interventions. You've got your standard things like mTOR inhibitors, statins, metformin, dasatinib, etc. How they are already FDA approved. So here we're talking about repurposing existing agents, which is something that longevity field is really, really should and can make use of, because they act on the pathways of interest and what we can look for in terms of outcomes for age-related diseases. I'd really recommend reading through this comment because it provides a really useful case study. Similarly, we published a fantastic paper earlier this year looking at targeting biology of aging using mTOR inhibitors and with specifically to improve immune function. So this is Joan Manick's paper, and it's really brilliant. And what they looked at, which I thought was really kind of elevated it from the standard research in this field, is they were trying to see whether the oral mTOR inhibitor upregulated antiviral responses and then had a clinical endpoint of decreasing the incidence of respiratory tract infections. Now, this had some complications specifically because of FDA approval and changing FDA approval at the last minute based on the phase 2 results. But that being said, this is definitely the way to go because you're looking here to see whether or not these mechanisms, these inhibitors of the basic mechanisms of aging have a wider clinical effect. And this matters because when we consider best practice for publishing longevity medicine, what the field really needs is studies that fit within the wider clinical medical sphere. So, I've taken this from a talk on best practice in publishing more widely in clinical medicine, but I think it's really important that the field considers it. So what we need in all clinical medicine, but I would argue especially in longevity medicine, it needs to answer a relevant question in an important population in the appropriate way at the opportune time. So you have to read the paper and at the end, you have to understand what the point of it was insofar as it relates to clinical medicine. There are many publishing vehicles and conferences and so on that relate to specifically mechanisms of aging and development. That's fine. But as we target longevity medicine, we need to focus on the clinically actionable piece. And I wanted to walk you through kind of what editors look for and what's important in these studies. So, because I think it's something that increasingly the fields are going to butt heads on, because longevity medicine is, I'm not going to say it's a cult in the sense that, it's by no means a cult, but if you get it, you get it. You understand the importance of longevity. You understand why it is that targeting aging as a process itself has such a huge benefit to bring to it. And I think people often forget that a busy clinician is not thinking long-term population science. What a clinician is thinking is, what is going to make my patient better? What is the simplest thing that's going to improve the health of my patients? How is this going to be useful? How can I use this? So one of the things to flag is the importance of using robust methodology. Just because it's a young science doesn't mean we can have sloppy science. So you've got to have an appropriate sample size so that the study can be significantly powered. Not significantly, but sufficiently powered. You've got to make sure that you've chosen an appropriate study design to answer the question in hand. And you've got to have strong support for your conclusions. You've got to use appropriate guidelines. I'll come to that in a second. And you have to make sure that the results are sufficiently generalizable to be of interest to a wide audience, because fundamentally that's what clinical medicine is. It's a huge audience, potentially, especially for longevity medicine. It touches on every sphere. So you've got to make sure that people can understand why this is potentially important. I've got here the sort of the pyramid of clinical studies that one can do in this field. And you can see it goes all the way up from expert opinions, which is essentially a lot of people sitting around and agreeing with each other, not to dismiss it because it is important, but it is the lowest level of evidence, all the way up to systematic reviews. And what we are missing so much in clinical medicine, in longevity medicine, because it is difficult, is randomized controlled trials. And those together with cohort studies are really what we need to see coming through, being designed well. One of the things I really wanted to highlight is, as we try and push for longevity medicine to become more mainstream, you have to remember that mainstream medicine has an unbelievable amount of studies coming through. So if you think about cancer, for example, in the cancer field, you could argue that tackling aging directly is going to have a huge impact on cancer outcomes. That is as maybe, but the money, the interest is still with trying to cure people with cancer. So you have to make sure that you clearly communicate in your study how this is going to have an effect. And you need to design studies that are going to show people that it will have an effect on age-related diseases as well as aging itself. This is something for best practice. These are the reporting guidelines for the main study types. I would strongly recommend that when you are designing studies for longevity medicine, you go away and you have a look at these things. They are not optional as you move into mainstream clinical medicine, medical practicing, especially things like Consort, Strobe, Prisma. They've been designed, they're unified, and it's not just the Lancet that uses them. It's basically every high impact medical journal will require formatting and reporting it to these standards. And very detailed reporting guidelines are available online. I'd strongly recommend you use them. Poor practice, which basically means that your study has much less likelihood of making it into a large mainstream clinical journal, is things like poor question selection, using an inappropriate patient group or endpoint. No comparator group. Well, how do we know that this is actually, how do we know that the intervention led to the outcome? Underpowered. It doesn't matter. I appreciate that these are difficult circumstances to do trials in, but at the same time, if you have a very, very small group of people, we won't know if the intervention is really leading to the result or if it's a statistical anomaly. Over-reliance on exploratory or ad hoc analyses. You can slice stuff any which way to try and get something significant, but it doesn't necessarily mean it's the case. And for clinical medicine, this is of critical importance, because otherwise, how can you apply this to a general medical practice? If you're looking at a predictive tool, it needs to be validated independently, or else how do we know that it works? For trials, you have to have a protocol. It has to be pre-registered. It has to not have any unplanned post-hoc analyses. All of these are absolutely critical for best practice in medical publishing. And you can't have incremental or confirmatory results if you want to publish in a high-impact journal. It has to be answering a new and important question. Plagiarism is obviously standard, but you'll be amazed at how often people self-plagiarize in terms of just repeating themselves over and over again, and something that we check for as standard in the Lancet group. So that was a lot of information. But I hope I managed to convey to you where I feel that longevity medicine needs to go in terms of breaking into mainstream medical publishing. If you have any further questions, please feel free to ask throughout today. I'll be at all of the workshop seminars chairing, so please feel free to ask me a question then. We've actually got a free webinar which I'll be running on publishing success in the Lancet groups, which will be on October 13, and sign-up details will be coming through. Please feel free to email me or go and have a read of the journal. Our editorial set out a lot of what I've been talking about as well, and everything is open access and free to read. Thank you very much for your time. I hope you have a fantastic time at ARDD and look forward to hopefully meeting some of you along the way. Thanks.